In this video, you're going to learn how to create a procedural mesh from a spline using the official Unity Spline Package. Yes, Unity now has native spline support, and you can use it too if you're using Unity 2021 or newer. Hey, Chris here from LlamAcademy, here to help you. Who? Me? Yes, you! Make your game dev dreams become reality by introducing you to a package that you probably didn't know existed. If you've never heard of a spline before, it's officially defined as a function defined piecewise by polynomials. And that's a bunch of math mumbo jumbo to say that it's basically the same thing as an animation curve. You can define a set of points and choose how do we interpolate from one point to the next point following a smooth path. This has a lot of applications in games for things like roads, telephone poles, chords, all kinds of stuff like that. Our use case here is going to be procedurally generating and animating a snake that will move across our level and try to eat the eggs that our chickens lay. This is in the free open source microgame Chicken Defense that you can play for free on itch and download the full project on GitHub for free. And before we get too deep into that, I do want to highlight that I ended up removing this from the game and replacing it with a standard mesh because the animation and rebuilding of the mesh constantly caused some performance issues that we'll talk about later. But regardless of the performance issues with constantly rebuilding the mesh, the ability to generate a mesh that follows a spline and move something along a spline is a really awesome functionality to have built into Unity. So even though this was removed, I still thought that was a fun exercise and an important thing to cover on the channel. So as I mentioned earlier, this is available in the package manager. So you can just go to Window, Package Manager, search at the Unity registry for spline, find that package, and then just click install and you're ready to go. I would highly encourage you to check out the samples as well, because Unity put a lot of time into a bunch of different examples that cover up a lot of things that are even more complicated than what we're going to cover today. Things like placing objects around a spline, making sure that they're aligned properly so you can create really cool roadways and all kinds of stuff. Enough about that. Let's jump in to see how can we make a snake. So like I said earlier, I've actually replaced my snake models with an actual snake model because using the procedural generation one was not super performant when I had several snakes going. But I left all of this in here so we could play around with it. If you're following along with the project, you can enable the spline animated object and disable the root object underneath the snake. How this works is we have a spline container which contains one or more splines. It will generate a mesh for us automatically, and we've applied some material that just has a snake-looking texture. We have the spline extrude component, which we can create the mesh for, and now we get basically a cylinder because I have all the points of the spline aligned in a straight line, every 0.125 units. We've created 8 knots, which are basically just points in a line. And if you've ever used the line renderer before, these are very similar to the positions on a line renderer, but they have a little bit of extra configuration on top of them. We can control how do we interpolate from one position to the next, either using auto, going linearly, or using a Bezier curve. I found that using Bezier curves wasn't quite as nice as just letting it do auto for this particular use case. If you're doing manual placements, probably you can get some cool results with Bezier curves, but auto worked perfectly for me on this snake. So all of these are the exact same, which was a little bit annoying to deal with when I wanted to set them up in the first place, because you can add knots and then you have to manipulate the point. And if you want to play with the distances here, you have to come and update all of them. And it wasn't super straightforward on how to do that with code, which I did try to do. That could have just been a me problem though. There's also a closed option, which will close your spline. So you can see here, it goes from the endpoint back to the beginning. For this, we didn't want that. I have a cylinder for the head and a tail that comes down here, which was a static mesh. And we just position these based on the spline container first and last points, which we'll talk about in a second. The spline extrude here allows us to control how fat our spline is, how many edges it has. You can make a cube, a cylinder, a nicer cylinder, an insane cylinder, whatever you like, and how many segments per unit you have is how many little segments we'll have in between each of these knots, which makes it much smoother or less smooth. And the cap ends here shows you if you want this thing or not. You can also control how far along the spline this thing has generated, which is pretty cool. Not useful for a snake, but in general, pretty cool. This auto regenerate geometry is really the crux of my problem. It wasn't super performant to regenerate the geometry when we're modifying it every single frame. And we'll look at that in a second. Even when I limited it to only 15 FPS, whenever I had several snakes going around, I had terrible FPS and almost all the CPU time was spent rebuilding this geometry. So without any code, we can have this thing. And if you manipulate the positions here, you can see kind of what's going to happen is we're going to manipulate all of these positions back and forth to have the snake go slither across the ground. And here we can see the segments per unit. If we go 1, it becomes very angular. 4 is a little bit better. I found 8 to be enough most of the time. So the snake's going to move like this. If we increase the rebuild frequency of the spline extrude, it becomes more smooth. We have 120 FPS animations here. Yeah, since we just have the one, let's leave it at 60. So the snake head moves back and forth, and even the tail wiggles back and forth. So we align the cylinder here and the tail here, and then rotate it along with those knots. If we increase the max width offset, we make it go farther back and forth, and the speed controls how fast he's going to slither like this. Let's hop into that code. All we're doing in this class is getting a reference on awake to that spline container and setting our default head and tail rotations. That's important to have those rotations, so as we get the offset rotation from our knots, we can correctly align these to those knots. Everything happens in update. You could throttle this with a coroutine or something like that, but I chose just to do an update. So we get a reference to the spline, we get the knot count, and we know that we only have one spline here, so we don't have to worry about having multiple. What we do is iterate from the end of the spline to the beginning of the spline and apply a distance damped sine offset to the X position of the knot. This is a really cool application of using math to do animations. We know a sine wave moves periodically over 2 pi, where it goes from -1 to 0 to 1 back to 0 over a 2 pi period. So we calculate a distance damping factor with I over knot count, and then provide to mathf.sine I times mathf pi divided by 2 plus time.time times speed. Then we multiply that output by the distance damping and the max width offset. That means the closer we are to the starting point, I equals knot count minus 1, the more we will move on the X. And the closer we get to the end, the less we will move. We chose mathf pi over 2 as our multiplicative factor with I to make each increment of I map to a corresponding specific value on the unit circle. We then smoothly move off from that preset position on the unit circle by time.time times speed to give us that smooth animation. Once we've updated all of our positions of our spline, all we need to do is make sure that we assign the head and the tail to be at the right positions. So the tail is at knot 0. We can get the rotation of that knot and set the tail transform local rotation to be that rotation plus our default rotation. And we can also set our local position to be that knot's local position, so it stays perfectly aligned with the knot every frame. Then we do the exact same thing with our head using the last knot. Now I've complained about the performance of this. Let's take a look at how that actually works out. So we can see we're running at 200 FPS minus some spikes that come up very frequently. This comes from Spline Extrude Update, which you'll remember is called because we're auto-regenerating geometry. So this is all these spikes correspond to 15 times a second. You can see how this will go bad if we start increasing the number of splines animated that we have. So we take the snake and we go ahead and just duplicate him a few times. Uh-oh, they're doing stuff. So already with just 4, our spikes become more prevalent. Just to try it out with a few more, if we duplicate them again, and now with 8, my performance has totally tanked to the point where I'm not ever getting 200 FPS anymore. We're really getting something like 10, and almost all of this time is coming from Spline Extrude Update. If we were to just play with this, having a single snake where it rebuilds at most once a frame, we still have quite a bit of time coming in here, something to the tune of 8 milliseconds. So obviously 8 milliseconds for updating a single spline mesh every frame that only has 8 points on it is quite a bit. That's why I ended up replacing this with just a standard mesh that's animated and moves around on its own. It ended up looking better and performed significantly better. So while this particular use case didn't make it into the game, it was still really awesome to see that Unity now has a native spline implementation, so you don't have to go make your own little thing for it. You can just go pull whatever Unity already has for us. This has honestly been something that I wished Unity had for a long time, and I'm really happy to see that it is there now, and I hope you are too. There's a bunch of use cases like moving something along a path, defining pathways, roadways, having telephone wires, all of these types of things we can do with splines, and they're really convenient. If you got value out of this video, Make sure you've liked and subscribed to help the channel grow, reach more people, and add value to more people. And if you wanted to show your support for the channel, there's a few ways you can do that. One, you can get yourself some LlamAcademy merch to rep the channel. All of these are sustainably sourced materials, and all but one of the shirts is made with organic cotton. You can, of course, donate on Itch to support the project if you're getting value out of the project as a whole. You can use the affiliate links down in the description to do your asset store or your humble bundle shopping. Clicking through those gives me a small percentage of the purchase price at no additional charge to you. And of course, you can leave a super thanks or become a YouTube member or a Patreon supporter. If you do that, you'll get access to a private Discord server only for those supporters. You'll also get recognized at the end of every video, and starting at the awesome tier like these folks, you'll get a shout out as well, like Ivan, Iphiobolis, Perry, Mustafa, and Jerematic. There's also all of these great supporters as well. Thank you all for your support. I am so incredibly grateful.